So from the solar eclipse, we studied water earlier, and we gathered data for the last almost over 3 hours, from 8 o'clock in the morning till about 11:30 in the morning. And so you see that's the Biowell. That's the latest edition of the Biowell 2.2. There's a water electrode immersed into a glass of water. You can see the full electrode is immersed in there. That's connected there to the USB, and now with all the charts and graphs, we have done the calculations, and this calculation is showing us the intensity, and the intensity begins here. We look at number 2, partial eclipse begins, and these are measure of photons, photon count in relative units. So we see photon count 2, 3 is the peak of the eclipse, and there's the peak of the eclipse, and then we come to the end of the eclipse, and now we see that as the eclipse ends, the intensity begins to grow. Slight increase in intensity. So we see the level of photons, so the level of light that's absorbed into the water is automatically, naturally beginning to get enriched and empowered. So now we'll go to our next chart, and our next chart is energy. And let's take a look here. So similarly, we can see that the partial eclipse begins, and there's the partial eclipse in terms of energy values. This is in joules, so it's roughly about 0.46 joules. Then we see a gradual increase as the peak of the eclipse, number 3. At peak of the eclipse, it is roughly 0.64. At the end of the eclipse, it is 0.67. Now we are talking about energy, and then towards the end of it, it continues and increases to 0.67. So there also we see that there's a gradual increase in the activity of the energy levels. And now let's look at the actual statistical variance over here, the standard deviation. So standard deviation begins as the partial eclipse begins, it shoots way up to like a very high value of 260, maintains it to number 3, which is the peak of the eclipse. And as the eclipse is ending, you can see that there is a massive drop. It has dropped all the way from like 259 down to 99, and has maintained a very steady pattern afterwards. So it shows that during points of eclipse, there is high level of disturbance in environments, which is why we are also advised not to be too far exposed into the environments, because it also shifts the values of water, shifts the values of energy. Are we not all water? Yeah, we are. So what is this reference to when we come to the term entropy? Entropy is change of state, degree of chaos in systems, and so there is entropy. So we can see that entropy level also is at the start, is right at the beginning was in higher mode, and we can see it has been lowered, and it gets lower as the entropy begins to fade away. So which means that we are restoring back towards normal. Overall takeaway from here is the standard deviation curve, and the standard deviation curve is a very important aspect to show that indeed there has been a significant shift in the behavior of the water to the environment, as we've occurred and conveyed earlier. Thank you.